Hello everyone, welcome back to Sermon City Prep. Today we're tackling chapter 21 circles of the College Panda Math book. Let's start with question 1. So there is a square ABCD in an inscribed circle. If the radius of the circle is r, what is the length of arc APD? So always the equation for the circumference of a circle is 2 pi r. So let's write that down. And we know that the square divides the circle into 4 equal arcs here. So there's 1, 2, 3, 4 here. So all we need to do is to find the length of an arc, which is APD here. We can just divide this arc by length 4. So we'll get pi r over 2, so the answer is B. Question 2, there are 3 congruent circles tangent to each other and lies on the diameter of a larger circle. If the area of each of these smaller circles is 9 pi, what is the area of the larger circle? So first what we need to do is to find the radius of each of the smaller circles. So we can do this by working in reverse. So the formula for the area of a circle is pi r squared. And we know that the area is equal to 9 pi. Now if you solve for pi, we will get, if you solve for r, we'll get r is equal to 3 here. So we know that the radius of the outer circle is equivalent to 3 radius of the smaller circle, right? So we just multiply the radius of the small circle by 3. And then we get the radius 9. And the area of the larger circle will be pi r squared, where r is equal to 9. So the answer would be 81 pi. So the correct answer is D. Question 3. There is a circle with 36 pi as an area, and it's divided into 8 regions. What is the perimeter of one of these regions? So again, what we can do is to find the radius. So we know that the formula for the area is pi r squared, and that's equal to 36 pi. Now if you solve for r, we should be getting r is equal to 6. And the circumference of a circle is 2 pi r, where r here is 6. So we get 12 pi. And the perimeter of one region is made up of 2 radii, right? So there's 2 radii here. And also there's 1/8 of a circumference. So what we can do is add the 2 radii, and then we add the 1/8 of the circumference. Because there are 8 congruent regions, so we have to divide it by 8. So the circumference is 12 pi. So we should get 12 plus 1.5 pi, so the answer is C. Which of the following is an equation of a circle in the xy plane with center -2, 0 and an area of 49 pi? Okay, so we can just solve this using, again, pi r squared. So pi r squared is equal to 49 pi here. And again, solving for r, we get r squared is equal to 49, so r is equal to 7 here. And the standard form of a circle with center, hk, as a center, and radius r, is x minus h squared plus y minus k squared is equal to r squared. This is something you must remember as it's a prevalent formula. So now all we have to do is to plug in. So we know that the center is -2, so x minus 2 is plus 2 squared, plus y minus 0 squared is equal to 49. So which of the answer options give us this answer? It's option D. Okay, moving on to question 5. In the figure above, angle ACB is inscribed in a circle. The length of a minor arc AB here is what fraction of the circumference of the circle? So what we do know is that the measure of arc AB is twice the measure of the inscribed angle, right? So since angle ACB is equal to 30 degrees, the arc of AB must be equal to 60 degrees. And we can calculate this we can calculate the fraction of the circumference by dividing the 60 degrees by 360 degrees, which is the circumference of the circle. So we'll get 1/6, so the answer is C. Question 6, in the figure above, AC is the diameter of the circle and the length of AB is 1. If the radius of the circle is 1, what is the measure in degrees of BAC? Since BAC here is kind of formed from the endpoints of the diameter, right? So there's a diameter here, and its measure is 90 degrees. Since AB here must be 1, and AC must be 2 because it's the diameter, then the triangle ABC should be a 30, 60, 90 degree triangle. Thus, angle BAC must be 60 degrees. Question 7, in the figure above, equilateral triangle ABC is inscribed in circle D. If the area of the circle D is 36 pi, what is the length of minor arc AB? This is another question where we use the area of the circle as a formula. So pi r squared is equal to 36 pi. And we solved this for question 3, so r is equal to 6. And the circumference of the circle is 2 pi r, where r is 6. And that will give us 12 pi again. And because we can see that the equilateral triangle splits our circle into 3 equal parts, and arc AB is one of those 3 pieces, right? So all we need to do is multiply this by 1/3, so we get 4 pi. Question 8, in the figure above, circle C has radius of 6. If the area of the shaded sector is 10 pi, what is the measure in radians of angle ACB? So again, the area of the circle is pi r squared, where r here is 6, so we get 36 pi as the area of the circle. And the shaded section here should be 10 pi, right? So it's 10 pi over what? 36 pi. It's 10 pi over 36 pi, and if we simplify this, we should cancel out 5 pi, and then we can cancel out 10 and 36 to get 5 over 18. And that's the shaded sector is 5/18 of the entire circle, which means that the central angle ACB must be 5 over 8 times 36 degrees, 360 degrees, and that will give us 100 degrees. And then we can convert this back into radians, because again we need to solve for radians. So we can just multiply by the formula, pi over 180. So we should get 5 pi over 9, making C the correct answer here. Okay, question 9, in the figure above, a circle has center C and radius of 5. If the measure of center angle ACB is between pi over 4 and pi over 2 radians, what is the one possible integer value of the length minor arc AB? So the arc length can be determined by r theta, right? Where theta is the measure of the center angle expressed in radians. Thus, this arc must be greater than 5 times pi over 4, which is roughly 3.9, and less than 5 times pi over 2, which is about 7.85. So we can choose any number between 4 to 7. Question 10, in the figure above, 4 circles, each with radius 4, are tangent to each other. What is the area of this shaded region? So all we can do here is to imagine that there's a circle here. There's a square here, right? There's a square that connects the center of each of these circles. And to get the shaded region, all we need to do is subtract the 4 quarters of the circles from the square. So a square always has the same length for each side, right? And let's say that length is 8 times 8. So that should give us 64. Because the radius is 4, we know that the length must be 8. And the 4 quarter circles make up one circle, right? Because there are 4 quarter circles here. And if you put them all together, they should make one circle, right? So we can assume that we can deduct this by making up one circle and finding the area of it. So the area of the circle is pi r squared, where the radius is 4 here. So we have 64 minus 16 pi, so the answer is D. The base of a right circular cylinder shown above has a radius of 4, and the height is 5. What is the surface area of the cylinder? So if we unravel the cylinder, we should be getting the base, a rectangular base, that is equal to the circumference of the height, circumference and a height that is equal to the height of the cylinder, right? So this should be 2 pi r here, and the width should be h. And the surface area of a cylinder is equal to the area of this triangle, of this rectangle, plus the areas of 2 circles at the end. So it should be 2 pi r h plus 2 pi r squared. So 2 pi times radius is 4 times 5 plus 2 pi 4 squared, and that will give us 72 pi, so the answer is C. In the figure above, circle P and circle U have each have radius of 3 and are tangent to each other. If this triangle is equilateral, what is the area of the shaded region? So to solve this problem, we must recognize that P and U each have the same area, which is pi times 3 squared, which is 9 pi. And to get the shaded region, all we need to do is to subtract out the unshaded portions from both of these circles, right? And because we know that this triangle is equilateral, then HPU here and also HUP here must all be 60 degrees, which means that the unshaded sectors are each 1/6 of their respective circles. So we get 9 pi plus 9 pi minus 1 over 6 9 pi minus 1 over 6 9 pi. And that will give us 18 pi, 3 pi, 15 pi. So the answer is D. If the area of the shaded region in the figure above is 24 pi and the radius of circle O is 6, what is the value of x? To solve this problem, let's let y be the angle on top of the triangle. And then we can solely construct this pi r squared minus y over 360 pi r squared. And that is equal to 24 pi, right? Because that's the area. And now we can just plug in the values for r. And then now we can solve for y. So that's 36 pi minus y over 10 pi is equal to 24 pi. So we can get rid of pi. And we'll get 36 minus y over 10 is equal to 24. So 12 is equal to y over 10. Thus, y is equal to 120. And if y is 120, then x and x have to add up to 60, right? So if 2x's add up to 60, then x must be 30. So the answer is B. In the figure above, circle A is tangent to circle B at point D. If the circle each has a radius of 4 and AC is tangent to circle B at point C, what is the area of the triangle ABC? So from the information given, we know that AB is equal to 8, right? Because we know that the circle has a radius of 4. So we just multiply that by 2 to get the diameter. And we also know that BC is 4. And because AC is tangent to circle B, angle ACB is a right triangle, right? So we can use Pythagorean theorem to find AC. So AC squared plus 4 squared is equal to 8 squared. So AC squared is equal to 48. So AC is equal to 4 root 3. And then we can solve for the area of the triangle, which is 1 over 2 times 4 root 3 times the height, 4. And that will give us 8 root 3. So the answer is C. Moving on to the last question, the equation of a circle in the xy plane is given above. Which of the following must be true? So if the circle has center, -2 and -4, and the radius is 2, if you draw the circle out, you see that it's only tangent to the y-axis, right? So the only possible answer here should be B. Because, no, it's not. The center of the circle is not 2, 4. It's -2, -4, and it's not tangent to the x-axis. So the correct answer here is B. Thank you very much for watching, and I hope you stay tuned for the next chapter upload.